Hello and welcome, this is Safa. In this video, we'll enhance images using histogram equalization, contrast, stretching, and adaptive thresholding. These are essential steps to prepare image for future extraction or segmentation. A histogram represents how pixel intensities are distributed. A narrow histogram means low contrast, while a wide one means higher contrast. MATLAB provides multiple methods to enhance image contrast. imadjust, stretch intensity, histeq, redistributed brightness, and adapthisteq works locally for uneven illumination. Okay, let's move to MATLAB and apply each method to visualize how contrast enhancement works in practice. Okay, here we started here by reading a grayscale image using the built-in put.tif. Then we visualize its histogram. You can see most pixels are clustered in a narrow range, meaning low contrast. Next, we apply imadjust for simple contrast stretching. Then histeq redistribute the intensity value for balanced brightness. And finally, adapthisteq performs local contrast enhancement, great for images with uneven lighting. And display result, and here. Okay, let's compare all results and observe how histograms spread more evenly after enhancement. Okay, here figure 1. Okay, here original image, original histogram, and figure 3. Okay, original, contrast, stretching, histogram, equalization, adaptive histogram, and here you can see. Okay, we'll enhance image contrast using 3 different methods. In the next video, we'll use these enhanced images for segmentation, separating objects from the background. And thanks for watching.